So if I'm using the confidence interval method, I have two scenarios. If I have a two-tailed test, then the confidence level that I want is equal to 1 minus alpha. If I have a one-tailed test, which is either a left or right tail, then the confidence level is 1 minus twice alpha. I need to know the confidence level to find a confidence interval. So I'm going to use this example, right, where we just did this. We have all the information we need. But now I'm going to find the confidence interval and use that method to come to a conclusion which should match the other two methods. Now I have to determine what kind of confidence level, right? What is the confidence level? So what kind of test do I have? It's a right tail test. So I only have an area in one tail, which means that it's a one-tailed test. So that means my confidence level is 1 minus twice alpha. So my confidence level is 1 minus twice alpha. Well, I have alpha. Alpha was the significance level given to me, 0.05. So let's find the confidence level. 1 minus 0.1 or 0.9. The confidence level 0.9, so I want a 90% confidence interval for this case, for the population mean. What interval of numbers represents the mean change in LDL cholesterol based on the situation, right? What are these values for the population? So I need a confidence interval for a population mean where sigma is unknown, right? I don't know the population standard deviation. We said that before. Sigma is unknown. T interval. T interval. Back to chapter 7. Back to confidence intervals, right? T interval. Let's go to my calculator. Where do I find T interval? The same way that I find T test. Stat, tests. But now I got to go down to intervals because I want an interval of numbers. T interval. T test if I want a test statistic or a p-value. T interval if I want an interval. Same idea. Do I use data or do I use stats? I have statistics. I don't have a list of numbers. So I'm going to go stats. And then my stats were over here. So my X bar was 0.4. My S, right? Because I know the sample standard deviation was 21. My sample size was 49. And I want a 90% confidence level. 0.9. Sorry, guys. Calculate. So here's my confidence interval from negative 4.6 to positive 5.4. So let me go back to my screen here. So my confidence interval goes from negative 4.6 to positive 5.4. This means that we are 90% confident that for the population, the mean change in LDL cholesterol is between this number and this number for the population. Now, how do I know, based on this interval, whether I reject or fail to reject the null? The null says, let me write that here next to it. HO says that mean is equal to 0, and HA says that mean is not equal to 0. I said, when using the confidence interval method, is the value that is claimed, is it in there? Is this number, is 0 in this interval? Is 0 between negative 4.6 and 5.4? Is it in this interval of numbers? It is. So if it is, that means it is a potential for the population. It could potentially represent the population mean. That means that I can't throw this out. It is a possibility for the population. So I have to fail to reject the null, right? The claimed value on the null, the claimed value on, the null is within the confidence interval. It's in there. 0's in there. If it were not in there, then it would not be a possibility for the population, which means that I could reject it. But it's in here. And this represents an interval of numbers that are possible for the population. I'm 90% confident in this interval, which means that I can't throw it away. So I have to fail to reject it, and therefore I come to the same conclusion that there's insufficient evidence. I'm failing to reject this. to support the alternative. That with garlic treatment, the mean change is greater than 0. So again, with your confidence interval, if this value, if the value on the null, the claimed value, if this number is in here, then I can't throw it away. I have to fail to reject it. If this number is not in here, then I could throw it away. I could reject it.